Hi there, my name is Mark, and in this video we are going to consider the symbols method and var method used by Sympy to generate objects of type symbol, algebraic variables essentially. Now what we're going to do is we are going to take a look at what a Python variable is versus a Sympy symbol, and then we are going to show you how to create some Sympy symbols and assign them to Python variables for convenience. Then I'm going to show you some ways on how to create Sympy symbols using the symbols method. And then we're going to get even a little bit more creative here by using the var method to save ourselves a bit of work. But there's a catch, and that catch will be the difference between using this symbols method and var method for generating objects of type symbol or algebraic variables. So let's get started in taking a look at what a Python variable is. And for this example, we are going to take a look at an object, and I'm going to take a look at this object X. And I'm going to be interested in the type of this object. Now let me just pull up this really cool feature of Google Colab where we can take a look at the variables that we're working with using the variable inspector. So here we'll be able to take a look at the variable name and its type. Now of course I can just run the cell for our object here, which is X, and it will return the type. So let's go ahead and run this. Now we see right away that X is not defined, so we are going to now define it as a Python variable. So I'm going to take X and assign it the value of 5. Now when I run the cell, I see that this variable is of type integer. So our variable name is X and it is of type integer. Now watch what happens when I update the value of the variable. I'm going to change it from type integer to type string, and notice that my variable inspector here allows me to keep track of the type without having to type the type function. All right, so now that we have a Python variable, what about this Sympy symbol? I mean, it is a variable if you're thinking in terms of an algebraic object. All right, so Sympy uses objects called what you think of as variables, but they call these symbols. And that is maybe to highlight the difference between a Python variable and a Sympy symbol. Now to use this, we are going to import the Sympy library as SP, and we are now going to go ahead and create an object which is of type symbol. So to do this, we are going to use sp dot, and we're going to use the method called symbols. And the argument of this method is the object that we are going to create as our symbol. In this case, it's going to be X. And when I run this cell, it returns this algebraic variable X. And we can see here that our variable has not been updated because that's a Python variable object, and ours is a object that is just of type symbol. Now the problem is I don't want to have to write this each time I want to define a variable, an algebraic variable, or in this case a Sympy symbol. So we're going to now assign this to a Python variable for convenience. But we can double check here that it does have a type, it is an object, and it is of type symbol. All right, so now let's get into some convenience. I want to be able to work with this object, so I'm going to now assign it to a Python variable. So I have this variable X, which is a Python variable, and I'm going to now assign it this object, which is of type symbol. So sp.symbols X, and you can see now that the variable X has been updated to type symbol in our variables inspector. Now, what if I wanted to just create an expression here? So x to the power of 2 plus 7x plus 12. And you can see here, this was typeset beautifully in the browser, and I didn't have to type sp.symbols with that text object X as the argument each time I wanted to include this algebraic variable of X. So now I want to show you how we can create these Sympy symbols using the symbols method, just like we did, but a couple techniques. Now there are quite a few of these, so you can check the documentation, but I will show you a couple. So let's start off with x is equal to sp.symbols x. I really don't need to do this because we already defined that previously, but for the purpose of this example, it will be okay. Now you see in our expression, I've added y, so I now need to define y also as an object of type symbol if I want this expressed as an algebraic expression. And you can see here that the variables inspector has been updated and we have an expression x plus y. Now there is an easier way to do this. What I could do is I could write x comma y and then as my argument here x comma y for the symbol objects. Now again, you'll see that it works, and you'll often see in the documentation and other people's code that they can also delineate these without a comma, so you can use this space as well. So if you feel more comfortable using a comma, use it. If not, use a space. Now, if I want to include maybe a third variable, in this case z, all I need to do is add it to my Python variables list and to my symbols. And if you want to use a comma, I feel a little more comfortable with that. So I'm going to run the cell and we can see that our expression is updated. Now, alternatively, you can go x colon z, and that will generate a symbol inclusive x through to z. So the notation is a little bit easier to use for longer lists of symbols. Now, in fact, let's go ahead and do an example where we generate an incredible number of symbols. Well, not incredible. We'll create a symbol for every letter in the alphabet. Now, I'm not going to assign each one of these to a Python variable. I'm just going to generate these Sympy symbol objects. So I'm going to go sp.symbols, and inside my text string here, I'm going to include these objects of type symbol. So I want to go A through to Z inclusively, and we were able to create all of those objects of type symbol very, very quickly. Now, in addition, I'd like you to note that in the variables inspector, nothing has been updated because none of these objects of type symbol have been assigned a variable name. Now again, I'll show you one more example. So we have sp.symbols. In this case, I want to create maybe some variables from a sub 0 all the way up to maybe a sub 9. And again, it's able to very quickly generate these objects of type symbol. Again, these objects have not been assigned to Python variables. But what if I did want to assign each of these objects of type symbol to a Python variable? Well, you can already see that this is going to be a little bit of work. So for example, I would have to go a sub 0, comma, a sub 1, comma, a sub 2, yeah, and it's a lot of work. So there must be a more convenient way of being able to do this. And in fact, there is a method for this, and it is called the var method. And essentially what this does is it uses the symbols method to generate the objects of type symbol, and then automatically assigns these to Python variables of the same name. Now there is a caveat here, and that is when the Python variable is created, it is assigned to the global namespace, and that's going to play a part when we talk about the difference between the symbols method and the var method. So I've just cleared out my Python variables here, and traditionally, if we were just using the symbols method for generating these two Python variables, x and y, I would use sp.symbols. Now there is a way to generate these two objects of type symbol, x and y, and assign them automatically to the Python variables, x and y, and this is using that var method. So all I need to do is use the same syntax as the symbols method, so x comma y or x space y, and this will automatically, watch this, it's super cool, it generates our objects of type symbol for x and y and assigns them automatically to the Python variable of the same name. Super fantastic, a huge time saver, especially if you're generating a large number of variables. Now let me give you an example here just to show that it works. It was that easy, it was that convenient. But even if we wanted to include many more objects of type symbol and assign these to variables. So let's go ahead and do an example. So we're going to go sp.var, and we're going to create objects of type symbol d through to k inclusively. And notice that when I run the cell, all of these objects are now of type symbol, and they've been assigned to Python variables of the same name. That's incredibly convenient. Okay, so what's the catch? The good news is there is no catch for most users who are just writing a couple lines in a Python notebook or maybe a quick script. So go ahead, use the convenience of the var method to generate those objects of type symbol and have them automatically assigned to Python variables of the same name. Now, of course, there is a difference, so I'm going to go ahead and show you what that is now. I'm just going to go ahead and delete those variables, x and y, and now I can go ahead and define a function, which I'm going to call func. And within this function, I am going to create an object of type symbol and assign it to a Python variable x. Now, this variable is being defined within a function, meaning that it is a local variable and it's only accessible within the function. So if I go to the global namespace or my general program here and I call the function and then I say, hey, what is the type of that object x, I would expect it to return that x is not defined. And this is where the difference between the symbols method and the var method exists, because the var method is going to take this object of type symbol and automatically assign it to a Python variable. Now, when it does so, it automatically assigns it to what we call the global namespace. So let me go ahead and show you what I mean by that by changing symbols to the var method. So when this method is called within the function, that Python variable x is now being assigned to the global namespace. It's not restricted as a local variable within the function, so it's available everywhere, and that's very good to know when you're defining these objects of type symbol using this var method. Now, I could also do this by first having the variable x, that's a Python variable, and assigning it to the global namespace. And then I could go ahead and use the symbols method. Again, this should generate an object of type symbol in the global namespace because now x is no longer restricted to being a local variable. In fact, this is one of the reasons why the var method is not available for programming within SymPy itself, because we would be working within different methods. Now, I'm going to call this one more time, and it says that it is still of object symbol, and that is because x is now part of the global namespace. So let me go ahead and delete that variable x and go back, delete the delete x, and now when I run this function, I should be back into the local namespace and x is not defined. So hopefully that's cleared up the difference between the symbols and the var methods used by SymPy.